Hello, we hear me well? So not a common first slide, right? So I had three ideas when choosing this first slide. The first one was to get your focus, of course. The second one is maybe there is real money inside this private key. And the third one was to make you wonder about what if there is another way rather than using non-really secure private keys, but maybe using account abstraction, which is maybe the topic of this talk. So, hello everyone, I'm Lilian, I'm a security and formal verification researcher at Certora. Today I'm going to talk about account abstraction, so EIP 4227 and 7702. The question we're going to try to answer today is how to trust delegators, how to be sure that funds are safe when delegating to 7702 and flows are secure when using 4227. So for those who don't know about 4227 or 7702, let me give you a brief introduction before diving in. 4227 introduce an alt mempool for user operation, bundlers who package transaction and entry-point singleton contracts. No hard fork required, works today on any EVM chains. 7702 on the other side temporarily converts a user signing account into a smart contract wallet for a duration of a transaction by introducing a new type of transaction, which is 0x04. And it requires the PEC2 hard forks. The main idea is to enhance the user experience and security without permanently altering the account structure. So same address, but now programmable. And both of them expand the attack surfaces. Yeah, I forgot about that. Let's deep dive into the 423 architecture because it directly explains the attack surface. So first we have a user creating a user operation. These are pseudo transaction containing up to 15 fields like user, senders, call data, gas parameters, paymaster if used, signature of course. This user ops goes into a user op mempool. These are different from the hetero mempool we all know, and it's optional. It's more and more used, but it's still optional. And then we have the bundler, which are off-chain actor that collects the user operation and, as you may have guessed, creates a bundle transaction with the valid user ops. Then we have the entry points. The entry points orchestrate the simulation and execution in two phases. So first validation loops, check signature, check user paymaster funds if used, and then the execution loops, which actually runs the operation. Finally, we have the post-up, which is also optional. And this is where, if used, the bundler gets compensated by either the user or the paymaster. About the entry points, keep in mind that it's a single point of failure by itself. That's why it adds multiple audits and has an active bug bounty and hack proof. About 7702, the architecture is simpler, but the implications are more profound. You have your EOA, you sign an authorization tuple containing chain ID, address, non-signature, and then the EVM will write a special code to your EOA, which is 0xEF0100 plus the delegate address. And then when your EOA is triggered, the code will run in your EOA context using your storage, your balance. Two things to remind about 7702 for now. The first thing is that the delegation is revocable. You can delegate to address 0 to clear the code, and you can still sign raw transaction for now. I mean by that even when delegated to a multisig, the private key can still sign raw transaction. So let me crystallize the key differences here in terms of layer. 4227 is application layer, no fork required. 772 is protocol layer. It required the PEC2 hard fork in May 2025. In terms of account model, 4227 introduced new smart account address, so migration required. 772 on the other side preserves the existing EOA address, so no migration required, which is huge for UX. In terms of infrastructure, 4227 introduced bundlers, alt mempool, entry points, so external actors are required. And on the other side, 772 use native transactions, so no extra actor required except delegator, but usually you either trust a delegator or you develop it yourself. And finally, in terms of private key, in 4227 it's 7 optional. You can have fully smart accounts. And 772, as I said, always retain sudo access. You can remove the key control for now. And in practice, they are complementary. I mean by that, you will see EOA delegating via 7702 to 423 compatible wallets code by using paymaster for gas sponsorships. This is the likely production pattern. So let's see some exploit, and then the idea is to map the attack surface. When we're talking about account transaction for 227, usually it means Alice will pay gas for Bob's. And two questions here that can come to mind. The first one is, what if Bob has a possibility to not refund Alice? And what more than that, what if Bob has a possibility to join Alice is? Then one thing to know about the 4227 architecture is that the entry point will charge a 10% penalty on the unused gas exceeding 40K. And this penalty is deduced either from the user or the paymaster. So let's see a paymaster gas drain exploit. This is a simple griefing attack. So we have an attacker that creates a malicious user robs. We will see why malicious later, but let's say the goal gas limit set by the user is 500. Then the paymaster agrees to sponsor it, because why not? The entry point execute, and the actual gas used is only 50K. So the entry point will say, okay, you ask for 500, I use 50K. It means that the penalty will be on 450K, meaning the 40K buffer, which is equal to 41K gas of penalty. And here, two problems. The first one is, what if the paymaster forgot to account for the excess penalty gas cost? It means a user can create a malicious user robs by setting the call gas limit a lot higher. But if the paymaster forgot to include the potential penalty gas cost, the paymaster will pay for the excess. And second problem, which is worse, you can design a malicious bundler that can be created to always trigger the penalty gas cost, and the paymaster will gently give to the bundler, to you, the penalties applied by you. It's like applying taxes on a product your client are forced to buy. It might remind you someone. And the fix is easy here. You just have to account for the potential penalty gas cost. So let's see something similar in 772. It's the more sphere scenario. It's well known, but it's a common example. So we have Alice that wants to use 7702 and wants to delegate to delegator A. Delegator A layout is simple. You have nonce in slot 0, U into 56, and you have balance in slot 1. And let's say after some couple of transactions, Alice slot are 6. Alice slot 0 nonces are set to 6, and Alice was smart and sold her BTC at 120K, like everybody in this room, right? And she has 10 million USDC in slot 1. Then Alice wants more fine-tuning, and she wants to delegate to delegator B. Delegator B layout is totally different. We have an array of U into 56 item in slot 0, and we have a mapping of data in slot 1. And then when Alice EOA is triggered, delegator B will read the leftover states from delegator A and will set the item that's belongs to 6, which basically will break the account. So the logic is corrupt because we have an unpredictable behavior, and it's pretty hard to fix because the storage layout is now and now. So simple takeaway here, remind that the EOA storage persists across redelegation. So let's see another 4237 example. One thing to know about the 4237 type of paymaster, that there are basically two kinds of paymasters. The first one is validation paymasters that are used mostly for gas sponsorships. So they are doing a lot of verification, validation to decide if a user transaction is eligible for gas sponsorships. And there are the ERC20 paymasters, the one we will focus on for this story. The ERC20 paymaster enable user transaction inclusion in exchange for ERC20's token equivalence. This kind of paymaster either charge the user before the execution, so before the entry point, or after the execution, after the post-op. So please raise your hand if you think that the paymaster should take the fund before. Okay, and raise your hand if you think that the paymaster should take the fund after. Okay, so a lot of... and no. So let's see an example where the paymaster takes the fund after, and here what do you think will happen if the user executes and revokes the approval as part of the execution phase? So it's easy, the entire the post-op will fail and the entire transaction will fail, which means that everything will fail, of course, but the paymaster still has to pay for funds. So here, the good answer is to take the fund before, because we always favor the protocol. But there are a couple of problems we have to face. The first one is that we must estimate the gas upfront based on gas limit. We will end up overcharging the user because you can predict the exact cost. You have to account for the 10% penalty, and you have to not be a victim of all the Oracle conversion risks that could happen. I mean by that DOS, decimal issues, and conversion price. So if you take the fund before, you will end up overcharging, which is a way to go. But if you take the fund after, there is a risk of undercharging the user or not charging it at all, because the user can revoke the approval during the execution. So yeah, golden rule, still pre-collect the maximum fund as possible before, and if there is excess, you refund the user. It's easy. About that, there is an ERC that tries to mitigate the simulation execution gap we have in 4237. This is the ERC 7562. This ERC basically do two things. The first one is that it bans opcodes that anything that could change between simulation and execution are banned. So timestamp, block, hash, base fee, coin base are banned. And it does one more thing. It restricts the external storage access rule. So basically, you can only read mappings where the sender is the key. So the takeaway for ERC 7562 is that it reduces the attack surface but doesn't eliminate the fundamental talk-to problem we have in 4227. And another edge case on 4227 is that during simulation, the storage is still maintained cold, which could represent a differences between execution between simulation and execution in terms of gas cost. So one thing to do about that is to have the entry point performing a view call before validation to kind of warm the storage slots. So this helps reduce the discrepancy problem we have here, but keep in mind that if your validation success depends on simulation gas cost versus, cold versus warm gas cost, you can still grieve the paymaster. So we have seen some attack, we have seen some defenses. Let's try to map the 4227 pitfalls we have fundamentally. The first one is about the signatures. This is where most implementation bugs live. So when you are discussing about signature for 4227, you have to do two things. The first one is you have to include chain ID, entry point address, plus the fees and gas parameter in the hash. This is really important. If you miss any of this, you enable replay attack. And second things, there are the valid until and validator fields that exist, so please use them. You really have to treat the signature as a library decision, and you have to bind the signature to the user up plus the hash for a user. This is really important. Second thing, you have to not revert on the bundler for invalid signature. Your bundler is an off-chain actor. So if you let someone spam your bundler, you enable DOS attack for it. So you have to let the entry point under the revert scenario. So your bundler must return the SIG validation fail, never revert on the bundler side. Number 3, this one is funny, but the original 4227 missed it. You have to verify that the message sender is the entry point on your paymaster, otherwise it's open door. And finally, you have to account for the 10% penalty as we discussed. There are a lot more. It will be too long to discuss all of them, but you have to maintain your validate user up as statelet as possible. You have to never rely on post-up for core invariant and keep the post-up as minimal as possible too. We can discuss this later if you want. Let's do the same for 7702. Here, 4 well-known critical attack surfaces. The first one is the chain ID. If you set the chain ID to 0, it makes the authorization valid on all EVM chains, so you don't want to do that for 2 reasons, because it's obvious, and the second one is because the same contract address on different chain may have completely different code. So please always specify explicit chain ID on authorization tuple. Second one is initialization front running. Remind that the 7702 has no init code, so constructor don't run in your EOA context. So if you want to set role permission owner, you have to do it atomically. I mean delegation and initialization in the same transaction, and never delegate to proxies or upgradable contracts, but only delegate to immutable and OGTech contracts, because your EOA, if your EOA is upgradable, it's a logic, but the guy that controls the upgradability controls your EOA. And remind that the same is true for 4227. The attacker can extract the init code from a user app and front run the deployments. Number 3, access control and delegation. This is where the 0xEF0100 belongs. So first, it's well known, but it has caused more than 3.2 million in losses. So I had to talk about it, but no longer rely on text.origin. And if you want to detect delegation in your smart contract, you can use message.thunder.code. Number 4, we have talked about this. Storage persists when you redelegate to a new contract. So against that, we have 3 layers of defenses. The first one is to use 7201 namespace storage to derive the storage load in a unique way. You can follow ERC 779, which is still a draft, I think, but it provides a redelegation standard for safe migration. And finally, it's not really handy, but you can clear the storage explicitly before any redelegation. I mean by that, you can do it by hand with Solidity or assembly code in your delegator contracts. So what's next for account abstraction security? There are 2 EIP worth knowing. Both are from Vitalik. You may know him. The first one is EIP 8141, which is called an omnibus frame transaction. The idea is to move 4227 from application layer to protocol layer, so no more off-chain bundler, no more entry point middleman. And the idea is to do that by introducing a new type of transaction, 0x06. About 7702, there is this new IP also, which is 7851, which aim to deactivate the private key, override undelegated EOA. So the idea is to provide a new precompile to deactivate the private key, and once disabled, the private key can only be re-enabled via the delegator itself or multisig. So, and about that, there is a follow-up EIP 8151 for EC recover, because here the idea is to make EC recover aware of deactivated private key. Otherwise, the bypass is easy. And 2 more things worth knowing. The first one is ERC 7739, already used by OpenZeppelin contracts, and RIP 7560, which aim to purge native rollup account abstraction by using 2-dimensional nonce. The key takeaway from this slide is that account abstraction is not a finished feature and has an evolving surface attack. So what we discussed today may not be true in 6 or 12 months. Thank you very much. Account abstraction is a deep and technical topic. So if you need any help, design review, manual auditing, formal verification, or even Web2 auditing service, please come to see us. I still believe that account abstraction is a really handy way to onboard the next wave of users. So if you want to deep more, please follow me or the Certora account annex. Thank you. If there is question, we have 2 minutes.
Thank you. Hello. Yeah. There is a part I did not quite understand. Is you say that you should never delegate to an upgradable contract, but my understanding is upgradable contracts. There are 2 parts. There is the proxy and the implementation. Actually, delegating to the implementation feels like what we should do because they are designed to be updated. They use namespace storage. And if you were to upgrade to a proxy, what the proxy does is it just redelegate to another address that is in no storage, which in our case would be the storage of the EOA. So it would just basically not work. So what exactly is the danger here?
You described the right case. I wanted to keep things as simple as possible, but you're right. If you know what you are doing, I would say you can do this kind of thing. That's right.
Of the 2 new EIPs, from a security perspective, which do you prefer?
Both are targeting different things, but I think that moving account abstraction 4.7 from application layer to protocol layer is a really good thing to do, because we have modules in 4.7, we have modules, we have a lot of things that can be fine-tuned, and this is where usually errors are found. Thank you.